here we have 2017. This is Leaving Cert Ordinary Level. This is paper 2, question 5, and this is a question on statistics. So we're told in a survey the IQ scores of 1,200 people were recorded. The mean score was 100 points and the standard deviation was 15 points. So assuming that IQ scores are normally distributed, the data are shown on the diagram below. So we're asked to fill in the missing numbers on the horizontal axis. So pieces of information that we're told in that was that the number of people included was, we surveyed 1,200 people and the mean was 100 and the standard deviation was 15. So the standard deviation tells us how spread out our data is. So when we have a normal distribution, so a normal distribution means we have a bell-shaped curve, our mean is always going to be in the middle. So our 100 is going to be our mean and our curve is going to be symmetrical. So if we get from between 85 and 100, the difference is 15. So this here is the mean minus 1 standard deviation on this side. So on this side, we're going to have to plus 1 standard deviation. So it'll be 115. So what we're going to do is we're going to plus a standard deviation each time on this side. And then we're going to minus on this side. So if we plus another standard deviation, we get 130. We plus another one, we get 145. So that's 2 standard deviations, 3 standard deviations. And if we're minusing another standard deviation, so it'll be minus 2 standard deviations. So we'll get 70. And if we're minusing another standard deviation, we'll get 55. So then we're told that a person is chosen at random from those surveyed. Use the empirical rule to find the probability this person has an IQ score between 70 and 130 points. So what we should know about the empirical rule is that when we have a standard normal distribution, so that just means it follows a bell-shaped curve. So this should be symmetrical. So say we call this our mean, this kind of symbol our mean, and we let this be our standard deviation. The empirical rule states that, say this is our mean in the middle, that if we add on a standard deviation on both sides, so if we have our mean plus a standard deviation and our mean minus a standard deviation, it says that 68% of all the data is within this range. And then if we add on 2 standard deviations, so the mean plus 2 standard deviations, and then the mean minus 2 standard deviations, we have 95% of all data. And then if we go within 3 standard deviations, so the mean plus 3 standard deviations and the mean minus 3 standard deviations, we have 99.7% of all data within 3 standard deviations. So what we are asked is we want to find the probability that the person has an IQ score between 70, so between 70 here and 130. So our mean is 100, so this is our mean. Here we are plussing 1 standard deviation. Here we are plussing 2 standard deviations. So that's 2 standard deviations up. Here we're minusing 1 standard deviation, minusing another. So we are within 2 standard deviations of the mean. So from our empirical rule, when we have a normal distribution, 95% of all data is within 2 standard deviations of the mean. So 95% of all data lies between 70 and 130. So therefore, the probability in that case that a person has an IQ score within that range will be 0.95. So that's the probability in that case. And then in the next part, we're asked to use the empirical rule to approximate the number of people surveyed with an IQ score between 85 and 115. So if we want to get the percentage, how much of the data is between 85 and 115, well, here's our mean. This is plus 1 standard deviation, and that's minus 1 standard deviation. So this is within 1 standard deviation of the mean. So within 1 standard deviation of the mean, we have 68% of all data. So 68%. So 68% of all of the people lie between 85 and 115. But we were asked to find the approximate number of people surveyed that lie within this range. Well, 68% of the people surveyed are to lie within this range. The number of people surveyed was 1,200. So we multiply 1,200 by the range. So 68% of the data lies within this range. So by 0.68. So that's 1,200 by 0.68. And then we get 816. So this gives the approximate number of people that lie within that range. And then the next part of that question, so we have a class of 24 pupils. So we have 24 pupils is made of 10 boys. So 10 boys and 14 girls. Chemistry is studied by 6 of the boys. So 6 boys chemistry and 9 of the girls. So 9 girls chemistry. So a pupil is chosen at random from the class. Find the probability that the pupil chosen is a boy or a pupil who does not study chemistry. So say out of the 10 boys, 4 don't study chemistry. Don't do, I'll just say C, and then 5 don't study C. So if we want to get the total number of pupils in our class is 24. So we'll put our whatever we have over 24. And we want the probability the pupil chosen is a boy or a pupil who does not study chemistry. So either a boy, which is 10, or a pupil that does not study chemistry. And then there's 5 others that don't study chemistry. So we're going to add 10 and 5. So that's going to give us 15 over 24. And that is our answer for that question.